sum that they gave me. Okay, so they gave me distance, I wrote it down. They gave me time, I wrote it down. They gave me my initial velocity, so I wrote it down. I then wanted to calculate acceleration, so I looked at my formula sheet, and I got that formula. Alright, I then substitute my values into that formula and solve for A, using my units, meters per second to the negative 2. Yeah?
Ma'am, do you always get a mark for writing out the formula?
Yes. Alright, you always get a mark for writing out the formula. Alright, so guys, quiet please. Our next question. A motorcycle is traveling east. Motorcycle traveling east starts from rest and moves in a straight line with a constant acceleration, and it covers a distance of 64 meters in 4 seconds. Alright, so starts from rest. That means VI is 0. We know our delta x is equal to 64. Delta t is equal to 4. You guys happy with how I got all those values?
Yes.
Okay, so now it says calculate acceleration. So now once again I look at my formula sheet, which will be given to you in the exams. Now I've got VI, I've got t, I've got delta x, I want to calculate my acceleration. So I'm going to use the same formula I used before. So I have delta x is equal to VI delta t plus half a t squared. Now I fill in my values, delta t squared. And my delta x is 64 is equal to VI, which is 0. Always put your values in brackets, and my time is 4. Alright guys, you have to write that. Even though we know that 4 times 0 is 0, I want you to fill it in like that. Yeah?
What happens if you don't write the values in brackets?
It's fine. It's just better because that's how they want it in matric, so I'm teaching it to you now. Okay? Because honestly, now I'm just preparing you for matric. Alright, so plus half A is what we want to know, and then I've got my delta t, which is 4 squared. So 4 times 4 is 16, divided by 2 is 8, 0, 64. Alright, which means A is equal to 8 meters per second to negative 2. You guys happy? Alright, so now I've got a new value. I've got A is equal to 8.
I am confused.
Alright, where do you get confused?
Ma'am, where did 64 go?
Alright guys, quiet please. So 64 came from my delta x. Delta x is 64 meters.
Ma'am, that I got, madam, but you see, the answer is A equals to 8, madam, but where's 64? Where, did you skip steps?
I said 64 divided by 8 gives me 8.
So when we skip steps, okay.
Yeah, I skipped the math steps. Alright, you guys happy?
Thanks.
Okay, so now, next it says we must calculate our final velocity. So I'm going to use the formula Vf is equal to Vi plus A delta t, because it's a nice easy formula. So I'll plug in my Vf is what I want to know. My Vi is 0 plus 8 times 4. What's 8 times 4?
22.
Okay, I'm trusting you. 32 meters per second to negative 1. Okay, happy? 24 meters per second to negative 1. The time the motorcycle had covered half the distance. Okay? So, what I first do is I say, okay, what's half the distance? Half the distance gives me a delta x of 32. Now I know my acceleration is still going to be 8. My VI is still going to be 0. So with those values, can I calculate my delta t? Alright, I don't have my VF. Can I calculate my delta t with those values? Alright, so guys, let's talking please. So now let's concentrate. Sorry?
What is N there?
Motorcycle. I didn't feel like writing motorcycle, so I said N. Alright, so now I'm just going to use the same formula again. We've got delta x is equal to VI delta t plus half a delta t squared. So delta x is now 32 is equal to 0 times delta t plus half times a, which is 8. Yeah.
Are you sure? Because you got the acceleration of the distance.
Hmm?
You got the acceleration of the distance, but they can half the distance.
So the acceleration will still be the same. The acceleration goes wrong, but it says here, and moves at a constant acceleration.
Oh.
Okay. So that's how I know the acceleration is the same throughout. It was constant acceleration. So I've got 32 is equal to 0 plus 4t squared. So 32 divided by 4. We did that somewhere already. Alright, it's 8. That's 32 divided by 4 is 8 is equal to t squared. So t is equal to root 8. Now you'll have to calculate that. You can't leave it as root 8 meters per second. You have to calculate what root 8 is. I don't know what root 8 is in my head. Should be 3 comma something. 2, sorry?
2,83.
Alright. 2,83 seconds. Alright, so then the final time will of course be our 4 seconds. Alright. 4 seconds. Guys, quiet please. So, these are our graphs of motion. So, with my delta x, so if my object is staying in one place, that means it's not moving. Right? That means my acceleration is 0 and my velocity is 0.
Madam, please explain that again.
If delta x remains at the same position, so this is, let's say, 3 meters. Alright, that means my object is not moving. It is still 3 meters from the wall. That means it doesn't have any velocity, it doesn't have any acceleration. Both are 0. Alright, if my object is moving at a constant velocity, uniform motion, that means it is moving. So my distance, my displacement is increasing. My velocity will be at a value which remains constant. Since I have constant velocity, my acceleration is 0. Alright, if this is a value drawn exponential graph. Alright, this is an exponential graph. Alright, so if it's getting exponentially faster, alright, that means my velocity is increasing and my acceleration is constant. So to get from acceleration to velocity to time, we use gradient. No, sorry, we use area.
Madam, please make an example with this road.
Alright, I'll do that now. So, and then to go from time to velocity to acceleration, we use gradient. Alright, so if I have an object that starts at rest, accelerates to that point, decelerates, and then goes at a constant velocity. So this is a velocity graph. Okay, this is 5, and that is 2. This is time 3, 5, 6. And this is time 8. At time 8, it stops moving. Alright, so if I want to calculate the total distance traveled, I'll first calculate the area of that triangle, then I'll calculate the area of that square, I'll then calculate the area of that triangle, and then that rectangle.
Can I make that understand?
So if I want to get the total displacement, I've written time instead of displacement.
Yeah.
Alright, so if I want to get the total displacement, then what I do is I calculate the area under the graph, so I can split this up into whatever kind of squares or blocks I want.
Madam,
Okay.
please label them as you are doing.
Alright, so I would just calculate first, I would calculate this one, 1, then I would calculate this one, 2, I'm going to use different colors.
Madam, but those are dotted lines, like separate them.
Take them apart.
Not necessarily, the dotted lines are just to show you what the values are on the graph. Alright, so this is mine, 2, this will be mine, 3, and then 4. So I'll calculate the area of those 4, add them together, that'll be my displacement. Okay. If I wanted to calculate the acceleration in the first 3 seconds, I'll calculate the gradient of that graph, that
So
line.
using y is equals to z in
Yes. Okay.
and is equals to y to the
Next is isotopes.
no. It's just
So can someone tell me the definition of an isotope?
Same protons.
No, different elements that have the same number of protons but a different number of neutrons.
Yes, elements that have the same number of protons and a different number of neutrons. Alright. So always remember your definition. I'm going to write it out for you.
Madam,
Yeah.
should we know the definition for the exam?
Yes, always know your definition.
No, but I remember you saying there was no isotope definition.
I forget these things. You know how long ago I set the stage? I haven't looked at it since then. Yes, I literally haven't looked at it since when I did the revision with you guys. Alright, so then I have my A, Z, and my element. Right, so guys, A is the number of nucleons. Not neutrons, nucleons. Nucleons is the number of protons and neutrons. Protons plus neutrons. Alright, you remember it because nucleon sounds like nucleus, and in the nucleus we have our protons and our neutrons. Thanks for whoever told me that one.
Leo.
Cool. Alright. So then we have our protons. Z is our protons. Alright, so you guys remember this is sounding familiar. Alright, so if I have the element. Alright, so I've got 28, 14, 13, and 15, 28, 15, and then 29 and 14. I ran out of letters, so we're going to A. X, Y, Z, A. Alright, so now I can say, which elements, name the elements X, Y, Z, and A. What elements are they? Alright, so you look at your periodic table, you look at the number of protons. X has 14, which means it is silicon. X is equal to silicon. Alright, and then you have Y, which is 15, which is phosphorus. What is Z?
Phosphorus.
Yeah, it's also phosphorus. And that is silicon. So we can say that X and A are isotopes of each other.
And y and z are isotopes of
Y and Z are isotopes of each other. Okay, is everyone happy? Alright.